Hello, and welcome to another Algebra 2 lesson. This is lesson 9.4. Our objective, graph sine and cosine functions. We're going to start with reviewing transformations. Describe the transformation of f represented by g. Because today in this lesson, we have to learn what does the parent function look like in a graph for sine and cosine, and then perform transformations on it. So, example 1, compare x squared to 4x squared. Multiplying by 4, what does that do? Vertical stretch by 4. And what about number 2? Look at the starting function x cubed, and now we have a negative 1/2 x cubed. So what does the negative do? It creates a reflection in the x-axis. And what about multiplying by 1/2? When you multiply by a number that's between 0 and 1, gives us a shrink. So this is a vertical shrink by 1/2. As long as it's a vertical stretch or shrink, when the number is bigger than 1, we get a stretch. If the number is between 0 and 1, we get a shrink. All right, number 3. 2 to the x power, compare that with 2 to the 3x power. So before we were multiplying the entire function by a number. Here we have more going on in the function, and we're multiplying just the x by 3. So that is a horizontal stretch or shrink. And when it's horizontal, you have to do the reciprocal. So it is a horizontal shrink by 1/3. All right, look at number 4. What's going on over there? Look at your original function, 4/5 to the x, and then look at what happened. We multiplied by 7 and subtracted 2 from the x. So multiplying by 7, it's a vertical stretch by 7. And then when we subtract 2 from the x, that's tucked in with x. I used to always say that was in the house. It's in the house with x. It's horizontal. And then minus 2 actually goes forward 2 because x's lie to you. So that is a horizontal translation. It's the h. If we think about hk, it's the h. It's a horizontal translation, so it's a slide 2 units which way? Forward. So that is to the right. Okay, look at number 5. What changed from sine of x to 3 sine of x? We multiplied by 3, multiplying a function by 3, what does that do? Vertical stretch by 3. Take a look at number 6. cosine of x, compare that with cosine of x plus 2. Well, x plus pi over 2. When we subtracted 2 from x, it went to the right. So if we're adding something to x, it's going to go the opposite way. So it's going to go left. So it's going to go left how much? Pi over 2. We haven't seen what that looks like yet, but we know it's going to shift left. Whatever the cosine graph looks like, we're going to take it and shift it this many units to the left. Right, there's transformations. Now let's figure out what sine and cosine graphs look like. Grab your unit circle, your reference sheet, wherever you have your unit circle saved. You're going to want that. I've got mine in my hand. Probably want to get yours out on your desktop. Okay, complete the table for y equals sine of x, where x is the angle measure in radians. So we are graphing in radians. When we are graphing sine and cosine, we're going to be graphing in radians. So if you are graphing with Desmos or a graphing calculator, you're going to want to make sure you're in radians. Okay, these negative numbers, I don't want to start with those. I'm going to start with 0. Y equals sine of x. When x is 0, what is the sine of 0? On your unit circle, 0 is over here, and the coordinates of that point is 1, 0. Remember, that is your cosine and your sine. So the sine of 0 is 0. Got our first number filled in. Okay, now look at pi over 4. Pi over 4 on your unit circle. What is the y coordinate of that point that lines up with pi over 4? Rad 2 over 2. All right, so that was pi over 4. That was here. Now we want to go here to pi over 2. So pi over 2 is up here. What is the y coordinate there? It's 1. All right, keep going. 3 pi over 4 is over here. What's the y coordinate? Rad 2 over 2. Keep filling them in. Pi is over here. What's the y coordinate? 0. Keep going. Fill them in. May want to pause your video. Fill these in. Keep going. Okay, once you've got the positive ones filled in, take care of the negative ones. For negative pi over 4, remember we are going backwards for negative, so negative pi over 4 would be right here. And we're using the y coordinate because we're doing sine. Fill them in. And now we're going to make a graph. While making a graph, it's going to help to know what is an approximation of rad 2 over 2. So grab a calculator, square root of 2, hit enter, divide by 2. We get 0.7, approximately 0.7. That'll help us in our graph. Plot the points x, y from part A. Draw a smooth curve through the points to sketch the graph of y equals sine of x. Okay, I want to start with 0, 0. I'm going to do it the same way I filled in the table. I'm going to start with the positive ones and do these, and then I'll go back and do the other ones. So going forward from 0, 0, pi over 4. There's no pi over 4 in here. What am I going to do? Well, here's pi, here's 2 pi, here's pi over 2, so that's 1/2. So 1/4 would be in the middle here. Okay, so pi over 4 is, remember this is 0.7. So when we're halfway between here and here, we're up at 0.7. So closer to 1 than 0. So you want to go up about 7/10 of the way up to 1. At pi over 2, we are up to 1. So line it up with pi over 2 and 1. Make your dot. 3 pi over 4, we are back at 0.7. At pi, it's down to 0. Take a look at our graph. Look how it's evolving. Kind of looks like a parabola. And what's our next point? We did this one, 5 pi over 4, and negative rad 2 over 2. So it's going to be negative 0.7. With 5 pi over 4, that's halfway here. Down to about negative 0.7. 3 pi over 2 is negative 1. 7 pi over 4 is halfway, negative 0.7 again. 2 pi is back at 0. Look at this graph. Let's draw a curve. So it's kind of like a parabola, and then like a parabola going the other way. This is a sine curve, or a sine wave. It can be called a curve, it's called a wave. And if we keep going, it went up to 9 pi over 4. That'd be up to 0.7. All right, now graph all these other points. It was counting by 4, so we needed some extra little lines in there. And graph. So 0's at negative 2 pi is at 0. It's really important to notice it doesn't zigzag. They're curves. This 0.7 is not at 0.5. If it was a straight line from here to here, it would have to go through 0.5, but it doesn't. It goes through 0.7. So it goes up faster and then slower. It's kind of like a bowl shape. So no zigzags. No zigzags. Nice, beautiful curves, kind of like bowls, or like kind of like that. Part of a parabola, part of a parabola. And there's our sine wave. All right, that's exploration number 1 for y equals sine of x. Let's try cosine. Same thing, fill in your table. I'm going to start with 0. Keep that unit circle handy. So remember, the coordinates of the points on the unit circle represent the cosine and sine of the corresponding angles. So at 0, the cosine, we're doing y equals cosine x, is 1. At pi over 4, rad 2 over 2. What about pi over 2? What's the cosine now? 0. Okay, take a couple minutes, fill this in. Might want to pause your video. don't worry, we won't have to make a table every time we graph these. We're going to figure out the pattern. And patterns give us shortcuts. Just need you to see at the very first time that if we take all of these points from the unit circle and write them down as x and y values, that we can then graph them and see what they look like. All right, start graphing your points. Remember that we need the little ones in between. We were counting by fourth pies. Okay, most important point. When x is 0, y is 1. That starts up here. At pi over 4, we're at 0.7. Remember, that's a 0.7. Pi over 2 is at 0. 3 pi over 4 is at negative 0.7. Pi is at negative 1. So pi negative 1. Keep graphing. Patterns give us shortcuts. I'm watching my patterns. Look at our curve. All right, if we do the ones going backwards. And there's our cosine graph. The most important point is that the parent function for cosine starts at the point 0, 1. And where did sine x start? Y equals sine of x. It started at the origin. Cosine of x starts at 0, 1. Sine of x starts at the origin. On the y-axis, it's on the origin. So its y-intercept is 0. Cosine x has a y-intercept of 1. And those are the parent functions for cosine and sine. Here's a list of their characteristics. The domain of each function is all real numbers. The range of each function is -1 to 1. That's as high and low as the y values go. So the minimum value of each function is -1, and the maximum is 1. The amplitude of the graph of each function is half of the difference of the maximum value and the minimum value. So the amplitude on both of these was 1. It went from 1 to -1, so what they're saying is that's a distance of 2 that it traveled, and the amplitude is half of that. So the amplitude is just 1 for these basic parent functions. Each function is periodic, which means that its graph has a repeating pattern. The shortest repeating pattern of the graph is called a cycle. The horizontal length of each cycle is called the period. Each graph shown above has a period of 2 pi. So every 2 pi, you've completed one cycle, and then it starts to repeat. The x-intercepts of sine of x occur at these spots, 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi. The x-intercepts for cosine x Those happen at the half pies. The half pie, plus or minus 3 halves pi, plus or minus 5 halves pi, plus or minus 7 halves pi. I don't memorize these. I memorize what the graph looks like, and we draw our curve. Okay, remember that for sine of x, when we graph it, it started at the origin, and it went up like a mountain and then down like a valley. And then for cosine of x, it didn't start at the origin. Its y-intercept was up at 1. It went down, and then it had like a bowl down here. So I call this a mountain in a valley, and this looks like horns. I could put a little face in here. Looks like horns on like a bighorn sheep. Okay, so this is where what one cycle of cosine looks like. This is what one cycle of sine looks like. Of course, you can make them match up. But I didn't show you that yet, that they match up. We'll talk more about that later. All right, characteristics of the parent function for sine and cosine. The domain is all real numbers. The range goes from -1 to +1. The amplitude is 1, and the period is 2 pi. Now, let's start making some transformations. The amplitude and period of the graphs, y equals a times sine of b times x, and y equals a times cosine of b times x, where a and b are non-zero real numbers, are as follows. The amplitude is the absolute value of a. It's that vertical stretch number. It's your amplitude. And the period, the length of one cycle, is 2 pi divided by b. Here is the b number. When there's a number in there, it'll be 2 pi divided by b. Parent function has period 2 pi. If we do a horizontal stretch or shrink, it'll be 2 pi divided by b, the absolute value of b. Each graph below shows 5 key points that partition the interval into 4 equal parts. You can use these points to sketch the graphs of y equals a sine bx and y equals a cosine bx. The x-intercepts, maximum and minimum, occur at these points. So basically, we memorize the shape. Whatever one period is, the 2 pi over b, that's what they put on that fourth mark out right here. 2 pi over b. You take that and then cut it in half. It says 5 key points. So we're going to cut it into 4 equal parts. So wherever you put that mark, doesn't matter where you put it, but then cut it in half and then separate each one of those sections into halves. If I'm doing cosine, I'm going to start up here and then go top, middle, bottom, middle, top. Top, middle, bottom, middle, top. Draw my curve. Curve it, curve it, curve it. And that's cosine. Well, what if it was sine? Figure out what the period is. Mark that. Cut that in half. Cut each one of those in half. But start in the middle. And then go middle, up, middle, down. And back to middle. Draw your mountain and your valley. And that's how simple we're going to make it. So we never have to make one of those big, long tables again. Graph a sine function, 4 times the sine of x. So find a. A is 4. So that's our amplitude. 1, 2, 3, 4. So that means the highest it's going to go is 4. The lowest it's going to go is -4. And there is no b value. So b is just an invisible 1. That means that the period, it's always 2 pi divided by b. So it didn't change from the parent function. So come out however far you want along the x-axis, whatever the period is, mark that there. Cut it in half, cut it in half. Okay, first I want to repeat this distance on the other side. We always want to draw at least 2 cycles of our graph or more. Now cut this in half and cut those in half. Sine wave. What does a sine wave look like? What's the general sketch of the parent function? It starts at the origin, mountain and a valley. Okay, so we start at the origin and we need a mountain and a valley. But we're going to go middle up, middle down, back to middle. Middle up, middle down, middle up, middle down, middle up, middle down. So we start from the middle, and then we're going to go, the next mark will go up to the top, to the 4. The next mark is going to come back to the middle. Next mark, we're going to go down to the bottom. So middle up, middle down, and back to middle. That gives us our hill and our valley. Kind of missed. And then we want to repeat that over here. So take that 2 pi, cut it in half, and then fourths. So we want to repeat, this was up, so now we need to go down to -4, back to middle, up, and back to middle. Draw another mountain and another valley. And there's a graph of g of x equals 4 times sine x. Ta-da! Let's try another one. Identify the amplitude and period, then graph the function and describe the graph of g as a transformation of the graph of cosine x. All right, here we go. Cosine x. What does cosine x look like? Cosine x starts up at 1, comes down, and then it has its valley and then the other horn. So that's what cosine looks like, the parent function. So we want to find A. A is 1/2. What's B? B is 2 pi. So then find the period. It's 2 pi over B. I just moved things around a little. B is 2 pi. And 2 pi divided by 2 pi is 1. So this time, the period is 1. So come out however far you want on the x-axis. You can make it just as far as before. We can do it smaller. Doesn't matter. Wherever you put it, label it 1. Make it symmetrical with a -1 on the other side. And then cut this into fourths. Our amplitude is 1/2. Cosine starts at the top. When you move forward to the next mark, go to the middle. So up, middle, down, middle, up. Here's a horn, here's the little face or the valley, and then there's the horn. So it looks like an animal. And then continue our pattern. We want to go backwards. Make sure you cut this in fourths. We're at the top, so go to middle. The next section, go down to the bottom, back to middle, and up to the top. And draw your curve. And we just graphed g of x equals 1/2 times cosine of 2 pi x. We have what kind of transformations do we have? We have a vertical shrink by 1/2, and we have a horizontal something by the reciprocal of 2 pi. 1 over 2 pi. Pi is 3 something, so that's about 1/6. Okay, that's less than 1, so that is a horizontal shrink. So we shrink it horizontally and we shrunk it vertically. Vertical shrink by 1/2, horizontal shrink by 1 over 2 pi. And that's example 2. I hope you're thinking real hard and following along. All right, now what if we shift it around? We do translations, H and K, H for horizontal, K for vertical, translating sine and cosine functions. The graphs of y equals a times sine of b times x minus h plus k and the cosine graph represent translations of the ones we just did. The value of k indicates a translation up or down. The value of h indicates right or left. A horizontal translation of a periodic function is also called a phase shift. Phase shift. When you shift it left or right, they call it a phase shift. Okay, step 1. Identify the amplitude, the period, the horizontal shift, and the vertical shift. So we want A, B, the period, the H, the K. Identify them all. Step 2, draw the horizontal line y equals k. This is called a midline. A midline. It is the middle of your curve, your sine wave or your cosine wave. It is the middle. Remember, we go middle up, middle down, middle up, middle down, middle up, middle down. We need to know where the middle is. Step 3, find the 5 key points by translating the key points of the other graphs horizontally and vertically. Step 4, draw the graph through the 5 key points. Here we go. Step 1. Find A, B, the period, H, and K. All of it. Okay, so A. A is 2. B is 4. So we use B to find the period. 2 pi divided by b. So that's pi over 2. That's really important because that's what's going to go out here as our main mark to get 1 cycle. And then we'll cut that into 4 pieces. Okay, back over here. A and B and the period, then we need H and K. I'm going to write it as coordinates of a point still, H and K. It helps me. H is still our horizontal translation. K is our vertical translation. H would be tucked in the house with X. There is no H. K is this number out here. So K is 3. So that means it's going to shift up 3. So 1, 2, 3. 1, 2, 3. All right, here's the crazy part. When we shift it up 3, that shifts the middle of our graph to y equals 3. This is our new midline. Before, our midline was on the y-axis. We are shifting it up 1, 2, 3 units. What's the amplitude? The amplitude is 2. So that means it's going to go 2 units up from there and 2 units down from there when we make our sine or cosine wave. Now, this next part you don't have to do, but here's what I like to do. I like to draw my other lines. so that I have a line for my middle and my minimum and my maximum. So all of my sine wave has to stay within these three lines. All right, you ready? What does a sine graph look like? Does it start up at the top or in the middle at the origin? Starts in the middle. We do a hill and then a valley. Okay, but our middle spot is no longer at the origin. We shifted it up 3, so now it's up here. But this is the middle of our curve. It's starting on the y-axis right here at 0, 3. Then we're going to go up, back to middle, down, back to middle. So middle up, this first spot, we're going to go up, go forward 1 spot, go back to middle, then down, and back to middle. Here's our first hill and our first valley. And we have 1 full cycle ending at pi over 2. Okay, and then we want to repeat the pattern. So from here, we were up, middle, down. Oh, I need my marks. How far is pi over 2? Try to replicate that on the other side for negative pi over 2. So you really only need to label 1 mark on either side and then cut it into fourths. And then we were at the middle, so we go to the bottom line, our minimum line, back to middle, up to the top, and back to the middle. And then we have 2 full cycles. Whew, a lot going on there. All right, on to example 4, cosine curve. What's A? Find A, find B, find the period, and then find your HK. B is 1/2. So 2 pi divided by 1/2 is the same as 2 pi times the reciprocal of 1/2, which is 2. So this time the period is 4 pi. So the first mark we're going to make, and 4 pi, so I'm going to draw it out a little bit further to kind of show that it's stretching. It's going to go to 4 pi. We cut that into fourths. What's HK? What's our horizontal shift? 3 pi. And our K, how far up or down did it move? It did not. So we don't have to draw our midline because our midline did not change. All right. Our period is 4 pi, but our new shift is the 3 pi. This is a phase shift of 3 pi. So this is 4 pi, this is 2 pi. I'm going to need some more labels in here to figure out how to shift forward 3 pi. That's 4 pi, 1 pi, 2 pi, 3 pi, 4 pi. So this that used to be my middle, my vertical middle, is going to have shift 1, 2, 3 up here. So this is my 3 pi line. When I go to do a cosine graph that starts at the top and goes down and then makes a little face with the horns, it's going to start up at whatever my maximum is. My amplitude is 5. So it's going to go up to 5 and down to -5. If you want to draw your maximum minimums, you can. But our middle's still our middle. It's kind of like that HK becomes like an origin. So instead of when we did the parent functions, we would use the origin as our starting point. We're going to use this as our starting point, except for cosine starts at the top. So this is where we need to be at the top, and then down to the middle, and then down to the bottom. So now we're going to back up. This will go back to middle, down, middle. So we're always going, moving one unit forward, back to the top, middle, down, middle, and draw your curve. Sometimes when I'm drawing my curves, I try to think of parabolas or bowls. So it really doesn't look like a cosine graph anymore because we shifted it 3 pi forward. But cosine graphs and sine graphs are really the same wave with different starting places. So they have different starting places, but they use all the same numbers. If you look at the numbers on the unit circle, the cosines and sine numbers, the coordinates of the points, it's all the same numbers. All right, and there's example 4. Example 5, graphing a reflection. So everything we already did and a reflection added in. Here we go. Find A, find B, find the period, and the HK. A is 2, but the negative gives us a reflection. So we also have this to worry about, reflection in the x-axis. So we'll do the same process, but we'll flip it over. So when we're supposed to go up, we go down, and when we're supposed to go down, we'll go up. A is 2, B is 2/3. So the period is 2 pi divided by 2/3, which is 2 pi times the reciprocal of 2/3. Three pi. All right, so we need a mark for 3 pi. One for -3 pi. And we're going to cut that into fourths. So cut it in half. Visualize half. Half. HK. H is pi over 2. And K is not there. Okay, so we don't have to worry about the midline shifting. So we're going forward pi over 2. Here's where this one gets tricky. With this phase shift of pi over 2, we need to know what pi over 2 looks like. And we're really counting by 3 pi. So if this is 3 pi, we cut that in half. 3 pi over 2 divided by 2 is 3 pi over 2. We cut that in half, so half of that is 3 pi over 4. Because we have to figure out how to move our starting spot to pi over 2. So here's a little bit of math I did over to the side. Pi over 2 is really just 2 pi over 4. And if this mark is 3 pi over 4, well then I need to know where 2 pi over 4 is. So let's break this into thirds, because then that's 1/4 pi, 2/4 pi, 3/4 pi. And then we'll do that with all of these. So we're going to break each one of those sections we already had into thirds. So we need to break 2 more lines in there. And then each one of those is pi over 4. That allows me to figure out where in the world my new starting point is. 1/4 pi, 2/4 pi. So there it is. That was a little tough to figure out. So that's my starting line. My sine graph usually starts from 0, 0 and does a mountain and a valley. So we start from here unless we shifted our midline up. Okay, so here's our middle. Our amplitude is 2, so we're going to go up 2 and down 2 from the middle. Let's put in our other dashed lines. So this is my maximum and minimum lines. My midline is the x-axis. We have to now make our graph. Okay, so we started here. Oh, I was doing blue. We want to go, our fourth sections were really 3 pi over 4. So from where we are, we have to move forward 3 pi over 4. So that's going to be 1, 2, 3 of these marks. And we normally would go from middle up, middle down, middle up, middle down. But we have this reflection. So instead of going up, we're going to go down. 1, 2, 3 of these little marks forward and go down. And then go 1, 2, 3 little marks forward and back to the middle. 1, 2, 3 marks forward and up to the top. And 1, 2, 3 marks forward and back. Wait, 1, 2, 3, that was there. 1, 2, 3, yes, and then back to here. And then we have a curve we could draw. And then we have to replicate that. So we're going to, and then we're breaking these into thirds. So we're adding 2 little lines between these other lines I already had. And then we are counting 3 little marks when we move horizontally. So 1, 2, 3, and we're going up. And 1, 2, 3, and we're back to middle. 1, 2, 3, and we're down. 1, 2, 3, back to middle, and that'll be enough. And this goes here. Whew. Graphing a reflection with all of those other things going on. Also, that's our sine graph for number 5. Which parent function's graph starts at the origin, sine or cosine? Do you remember which one had the hill and then the valley? That was sine. Good. Okay, big ideas assignment 9.4. Sound waves are sine and cosine waves. Amp it up to make it louder. So here's a quiet sound wave and here's a loud sound wave. Sound waves are sine waves or cosine waves. Keep going for more examples. Well, that other video is not made yet. Eventually, I will show you those examples. Have a great day. Thanks for watching. Ask questions. Practice, practice, practice. Check your work. Ask more questions. Have a great day.